Hi. Now let's demystify gradient of a line and angle of slope. We're also going to look at the relationship between them, how they are connected. Now let's start by deriving the formula for finding the gradient of a line. So let's have our Cartesian plane, and then we have our y-axis, and then our x-axis, and then let's pick 2 points again. Let's take this point and let's call this point x1, and for the y-axis y1, let's call this point A. So the coordinates of point A would therefore be x1 y1. Let's pick another point. Let's pick this point right here, and let the coordinates of this points be x2, sorry, and that of the ordinates, let it be y2. Hence the coordinates of point B will be x2 y2, x2 y2. Okay, so we're interested in the gradient of the line joining the points A to B. So let's link them up. And then, like we did before, I would just connect this line from here to here. And then I would call this point C. Now, the gradient of a line joining A to B is simply found by doing rise over run, okay? More like saying the change in y over the change in y, that's from here to here, over the change in x here to here. So here, this point will be y2 minus y1, y2 minus y1, and then the change in x will be x2 minus x1. Okay, so the gradient of the line joining A to B, which I can just tag this now, usually use small letter m, but let me just add this subscript here. So the gradient of the line joining A to B is going to be equal to rise over run, which is y2 minus y1 over x2 minus x1. Okay, so this is a formula for finding the gradient or the slope of a line. Okay, now how is this formula related to the angle of slope? So let's look at the angle of slope quickly. So let's say we have another line. Let's draw a Cartesian plane. Let's say we have a Cartesian plane drawn this way, and then we have a line running from, let's say, from here to here. Okay, now the angle of slope would be the angle that this line makes with the x-axis, so we can call it theta. Okay, and that's the angle that it makes with the x-axis. Now, how do we connect them? So let's connect this line to this point. Right there. Okay, I'll just have to do that again. So let's redo that line. So let's say we have we connect this line from here to here. Okay, so let's call this point A, here B, and then let's call this point C. Okay, now you can see that this is a right angle triangle. Okay, now remember we're interested in this angle. Now you know that from this right angle triangle, to get this, we can just do opposite over adjacent, okay, and that will be tan. So tan theta will be opposite, which is BC, over adjacent, which is AB. Now you'll note something, that BC over AB, BC over AB is simply the same as this over this, like rise over run, okay, rise over run. All right, so they are similar. Rise, the rise from A to B to C, and then run AB. All right, and that is the same thing as the gradient of this line, okay, the same as the gradient of this line. So it simply just means that the tangent of the angle a line makes with the x-axis, that is the angle of slope, is equal to the gradient. Okay, and to find that angle, we just do the tan inverse of the gradient, the tan inverse of m. Okay, so this is the relationship between the angle of slope and the gradient of a line, or the slope of a line. Okay, so this is theta is equal to this. All right, so let's take an example quickly. Now this example says the gradient of a line joining this point and this point is 1 over 2. Find the value of x. Okay, so here the gradient has been given, so we're just to look for this missing abscissa value for the first point. So let's just start by writing the formula. So the gradient of a line we already know is equal to y2 minus y1 over x2 minus x1. Okay, now you can see that they gave us the gradient m as 1 over 2. So we have 1 over 2 is equal to y2. Now, like I always say, it's always good to label this point so you don't get them mixed up. The first point, x1, y1, and x2, y2, the second point. So y2 is 2. So we have 2 minus y1 is 4 over x2 is 1 minus x1 is x, which is what we're looking for. So here we'll quickly cross multiply this with this. So I have 1 minus x will be equal to now 2 minus 4 of course will be minus 2. Okay, so we'll do 2 times minus 2. All right, so 2 times this, which is 2 minus 4 minus 2. So 2 times minus 2 is minus 4. Okay, and then I'll take 1 over. I have minus x will be equal to minus 4 minus 1. That's when 1 goes over. So we have minus x will be equal to minus 5, and therefore x will be equal to 5. Divide both sides by minus 1, just minus cancels, and you have that. So the correct option will be option C. Okay, now let's quickly look at another example that has to do with angle of slope. Okay, now this is a post UTME question from Unilag. It says find the angle of slope of the line joining the points this to this. Now remember the formula for angle of slope. Angle of slope was that we could just jump to theta, but let's start from here. Tan theta is equal to angle of is equal to gradient. All right, and remember that your gradient will be rather the angle of slope will be the tan inverse of the gradient. Okay, so all it means that we should just find the gradient first. So our gradient remember is equal to y2 minus y1 over x2 minus x1. Okay, and then our m will be equal to y2 minus y1. Could label them again: x1, y1, x2, y2. Okay, so we have y2 is 5, So 5 minus y1 is 2 over x2 is 5 minus x1 is minus 3. Okay, so you have to put that this way, minus 3. Okay, so now our m will be equal to 3 over 5 minus this is 8. So 5 plus 3, that's 8. So m is this. So m is equal to 3 over 8. Okay, which we can just quickly convert to, we can write in decimal form. Okay, that will be fine. So that will be 0.375. So 0.375. So now to get excuse me, to get the angle of slope, which is theta is going to be the tan inverse of 0.375. So we have theta will be equal to, I'll just do that quickly. So the tan inverse of 0.375 would be tan inverse of 0.375 is 20.556. So we have 20.556, 20 points, according to my calculator, 20.556 degrees. Okay, so you can see what they tried to do here. These two values are very close, 21, and so it's not going to be this. So if they approximated it, then theta will be equal to the nearest whole number. That would be 21 degrees. Okay, so that option C will be the correct answer. All right, and that's it. Okay, so in our next video, we're going to be looking at, we're done with this now and this, so we're going to look at the equations of a line. Okay, the equations of a line. All right, so I'll see you in my next video, and please do well to subscribe. Thank you.